Hi, this is a logistic growth model problem, number 23, and this is kind of toward the end of this section. Anyway, the logistic growth model is kind of like an exponential function, except this exponential function behaves like an exponential for a while, but after a while it levels off. So there's a ceiling. And the general form for the logistic growth model is this formula, and it's found in the book. And it's P of t equals C over 1 plus A e to the negative bt. Now, A and B are constants, and those numbers are depending on the situation, the actual problem, and that will be given to you in the problem. As a matter of fact, the C will be too. And C is the ceiling. So that's kind of easy to identify when it levels off. It's just the lone top number there. And the good thing about this thing, the goodness for you guys anyway, is that this problem, the formula will be provided. And they're just going to be asking a few questions. So you're going to either basically what I call plug and chug. You just plug the number in and get the output. So it's fairly simple. And but anyway, this is how a logistic growth model works. And unlike other exponential problems, which kind of grows indefinitely, and in reality, things don't really do that. So this is kind of a more realistic type situation when things level off. And but anyway, problem number 23 is this one, and it's about the number of proportions of people who will own a DVD player in United States, I believe. And the formula is 0.9 over 1 plus 6 e to the negative 0.32 t. Okay, so the ceiling obviously is 0.9, and I drew you a little picture of what it looks like. And so if you notice, there is no part of the graph that is on the left side of it, because this is talking about time. And anything over here is a negative. So that's, if you've been wondering, well, why do we always start it here? It's because it's time, and time cannot be negative. So, so this thing levels off at 90%. So what this is basically saying in this model is saying that the proportion of people who in the United States who own a DVD player will not exceed 90%. So there's always going to be a top 10% of people who will not buy a DVD player at all. And but anyway, these are the four questions that they're going to be asking you. What is the maximum proportion to own a DVD? That's the ceiling. So it's obviously the 0.9. So you would just say it's 90%. So there is no plug and chug. It's just identifying what the C is. And that's what they're asking. Maximum proportion. It's always that number there. So that means it's always going to stay under 90%. Now, they want to know what the proportion in the year 2000. So they want to know basically, since T is the number of years since 2000 in this situation, they want to know what the proportion in the year 2000. So in other words, they want you to identify the starting point, in other words. And all you got to do is just plug in 0. So this will be P 0. Like I said a while ago, it's just plug and chug for the most part. So you plug 0 in, and that's 0.9 over 1 plus 6e to the negative 0.32 times 0. And that will be still 0. And so 0.9 over that's going to be 0.9 over e to the 0 is 1, and 1 times 6 is 6, plus 1 is 7. So it's 0.9 divided by 7. So it's like 90% divided by 7, in other words. So, and I'll leave that part up to you with you and your calculator. So, and in the year 2005, same thing, plug and chug. So since T is the number of years since 2000, and they want to 2005, and they were nice enough in the book to tell you what T is, and T is 5. And they did not have to tell you that, but they were nice enough to do that. So it's just basically plug in 5. So it's the same thing as part B, except you have to plug in 5 instead. So it's going to be 0.9 over 1 plus 6e, and then you have to multiply 5 times the negative 0.32, and I believe that is like negative 1.6. And again, now this one's going to be a little harder to put into a calculator. I will say this, it's 0.9 divided by, with parentheses, 1 plus 6 times e to the negative 1.6, and then close that off. So what I'm saying is you need to make sure you put parentheses around that denominator because you want the 0.9 to be divided by the whole quantity. Without it, you're just going to be divided by 1, and then later on adding the 6 plus e. You don't want to do that. So that's how you plug it in. And again, I'm not going to waste time here with this video, just plugging numbers into a calculator. But it would be more than what this one is. This one's going to be around, I don't know, 12 or 13%, I guess. This was in the year 2000. You got to remember that. In the year 2000, 12, 13%. And then since then it's going to go up. So it's somewhere between like 13% to 90%. So if I was going to venture a guess, maybe 50, 60%, I don't know. So, but again, that's between you and your calculator. And then part D, they want to know when it will reach 90%. 80%. So 80% is going to be kind of right here. So it's going to be getting closer and closer to 90%. So it's at some year ahead. So what you do is you don't plug in 0.8. You set it equal to 0.8 because you want to know when the proportion equals 0.8, not t equals 0.8. So all you got to do there is set 0.8 equal to 0.9 over 1 plus 6e to the negative 0.32 times t. Now in this problem, the calculations are a little harder. You need to move this to the other side, but you're going to have an exponential equation, and that means logarithms are going to have to be used to solve it. Because every time you have an exponential type equation, you've got to do that. So again, you got to move the denominator to the other side, and you're going to have exponential. So you move all the numbers to one side and the exponential on the other side. Once you isolate the exponential, you need to take the natural log of both sides. That would allow you to bring the negative 0.32t down as a factor. And once you've done that, you just solve for t by dividing by your negative 0.32 and probably the logarithm also. So, but anyway, that's just, again, mostly just calculations with a calculator. But like I said, first thing you would do is move this over here and multiply by 0.8. So I'll show it to you real quick. It's going to be 0.8 times 1 plus 6e to the negative 0.32 times t equals 0.9. And then you would distribute the 0.8 and the 0.8 through here. And then once you've done that, you'll need to move the 0.8 to this side, so it'll be like 0.1. And then you'll divide by I think that'd be like 0.48. So you'll divide by 0.48 to the other side. So you're slowly peeling things away, getting the exponential by itself. And like I said, once you've done that get it by itself, you take the natural log, that brings the power down, and then isolate the t. So guessing maybe 10, 12 years, I don't know. But that's just totally a guess. I don't know. I didn't look at the answer before I started the problem. So, but anyway, that is 6.8.